welcome back. This is Joel, and in this video we'll talk about virtual port channels, right? So I do get certain questions like quite often on some of the basic topics, right? And like for example, virtual port channel, right? Or sometimes about DHCP or ARP and so on. Now the stuff which I do on my channel, they are generally, kind of not very, they are generally intermediate topics, right, which I kind of cover. So I thought, let me start a new playlist, right, maybe under the routing and switching domain here, and I will regularly update it with some of the most simple topics, right, so that people can kind of leverage it, maybe as they prepare for some of their exams like CCNA, CCNP, or maybe for an interview, right, or if you want to quickly pick a lab and try it out to learn the concept, right? So these are all some of the most important networking services, I would say, right? Some of the most important protocols, some of the most important features, right? Which I'll try to bundle in one single playlist, and I'll keep updating them so that I can kind of show you some interesting use cases with those, right? So we are kickstarting with the virtual port channel, which is like one of the most basic thing which is needed if you are very much of a data center person, right? So again, it's not going to be an in-depth virtual port channel session. Rather, it's mainly going to be configuration, trying out the various types of configuration, and kind of like a very much of a good discussion around the topic, right? But just to give you a gist about what port channel is, right? So let me spend probably a couple of minutes here. So if I have to tell you about port channel, I have to actually tell you a little bit about STP, right? So if you take a simple example, I know my pen is writing, yeah, that's good. So take a simple example, right? You say you have switch 1, you have a switch 2, and I don't know, maybe you have a switch 3 here, right? You have something like this. And imagine you have all these connected, right? In our case, if you want to kind of like relate to it, it's basically nothing but, you see, you have an access switch, you have a distribution, D2, right? So you can think of this as D1, D2, and access switch here, right? So when you have something like this, what happens, right? And imagine all these links are L2 links, right? Immediately your STP kicks in and is going to go and probably turn off one of the, or shut down, right? Or basically it makes one of the link unusable, right? That's the the good thing of STP is that it kind of prevents loops, but then the bad part is that you're basically going to lose that particular link, right? You're going to lose the utilization, right? And as a result, obviously if this primary link goes down, then obviously this link would become active, but then the whole point here is that at a time you're basically not going to have both the links active, because STP is going to kind of kick in, right? Now the same kind of holds good even if you have what you say, let me just get rid of this. So, or let me just draw on top of that, right? So imagine if you have a port channel, right? So what's that? Let me just get rid of that whole thing. Give me a second. Yeah. So the same thing, you have switch 1, switch 2, and you have switch 3 here, right? Now imagine you have a port channel. What is a port channel? Your normal port channel, right? You're gonna have like this, something like this, right? Two multiple links bundled together to basically increase your bandwidth, right? So this is a very common setup as well. Now even if you have a port channel, right, STP is still going to kick in, right? STP is going to kick in, and what it is going to do, it is basically going to disable one of this. In our setup here, it's probably, let's say for example, it's going to disable this one, right? But let's double click on this port channel, right, because that holds the key for understanding VPC, right? Let's look at this particular port channel here, right? Now you might ask a question, Joel, what happens if when the traffic basically goes through one of the link of this port channel, reaches here, right? Doesn't that traffic come back on the other interface, right? And doesn't that cause a loop, right? That's a very valid question, right? Because it's very, very much possible, right? If you're looking at this at the first instant, that's going to be a very valid question, because you have two links here. Obviously the traffic can enter one of the link and then kind of loop back and come on the other link, right? Now that is basically causing the loop. Then what's the use of STP? Though STP has already blocked one of the links, still we are going to have loop, right? Now that's actually not true, right? Because port channel by itself, though you see two links over here, port channel by itself has the loop prevention capability, right? Which means, what I mean by that is, when the traffic enters one of the link and when it reaches the other side, right, port channel is intelligent enough, right, to, I'm trying to, make it as simpler as possible, so I'm not going to get into the whole hashing algorithm and all of that, right, but the whole idea here is that when the traffic basically travels through or moves through one of the link of the port channel, right, the port channel is intelligent enough to not send the traffic on the other side. So it has a inherent, I would say, inherent loop prevention capability, right? So some intelligent person, what he did was, they thought, let's exploit this cool feature of port channel, right? Whatever we talked about just now, let's exploit this, right? But rather not do it between two switches, but rather do it, right, between two different switches. So what I mean by that is, if I get rid of the whole thing again, and let's draw the same thing again, right? So what they did was 1, 2, and 3. So they decided, how about we create a port channel, right, just like how we saw earlier, but this time we are going to create a port channel where on the other side you have two different switches. It's not between the same two switches, rather two different switches of this sort, right? So by doing this, what happens is, on the switch 3, which is here, with respect to switch 3, it still looks at that particular interface as a normal port channel, right? So with respect to this guy, right, he really doesn't know what's happening on the other side. So with respect to this guy, it appears as a normal port channel, right? The 3 basically still thinks that, this whatever this is basically connected to one single switch on the other side. But on this side, right, we are going to create what we call as a VPC domain, right? So we're going to create a VPC domain, and we are going to logically combine these two switches into one single switch, right? So from if you logically kind of rewrite this topology, it will basically appear like this, right? Literally like this, because the switch number 1 and 2 kind of like, forms a VPC domain, and with respect to switch 3, it just sees this whole thing as one single switch. So, when you look at this logically, it appears as a one single port channel. Now, what is the reason of doing this, right? We are basically exploiting that whole behavior which I told you, right? Because like I said, the traffic which is entering one of the interface, right, because it's a port channel, right, it is not going to come back in this, right, because we are exploiting the cool feature of the port channel. So that same thing what's going to happen here as well. Now between these two, this is a VPC domain, and we are going to have what we call as a VPC peer link and stuff, right? That's what we have here. We are going to configure that later. But the peer link, think of it as just like a keep alive, link, which is going to exchange some of the information, saying that, hey, look, this interface on my switch and this interface on this switch, we are forming the port channel, so that that information, all of that is shared between these guys. Why do we do that? Because any traffic which is entering here, right, on this particular port, it should not be again sent along this link and sent back, right? So you need some kind of a mechanism for both of these guys to talk to each other. So, right, so hope that was again a very brief understanding of VPC, right? You just need to realize that we started by using STP, right? But then people STP, and then there was obviously port channel as well. But STP kind of created a huge problem with reducing the utilization of the links, right? So someone decided that let's exploit this cool feature of port channel, right? Because inherently port channel has this loop prevention capability. So they said, okay, why not exploit that rather between two switches in this fashion? Let's put it in this fashion and kind of exploit that behavior. So now what is happening is, because of this whole thing, right, we are moved towards VPC where all the links are active, right? No, you are not going to have any links being turned off. I mean, STP is still there, but then like I said, if you look at here, right, when STP on switch 3 looks upwards, what it is going to find, it's just going to find one single link, one single port channel link, and it is not going to block it because it's just single link, right? So STP is still there, right? Don't think that because we have VPC, STP is completely removed. No, STP is still there, but then we have intelligently used the whole concept of port channel, between two different switches this way, and that way we are able to get the full benefits of all the links in our network, right? Hope that was useful. So now let's quickly jump on to the configuration. All right, so now we will probably jump into the configuration part of VPC, right? Pretty simple. We are gonna quickly finish this. So what do we have here in the topology is, I have a VPC domain here, right, which is formed by D1 and D2, right? These are all Nexus 9 kV switches. So we have D1 and D2 where we are gonna have the VPC domain, And then we have the access layer switches, which also I'm using as Nexus here, but literally you can use anything. You can even use IOL or virtual IOS switches here, right? So A1 and A2 are like your access layer switches, right? The access switches, and this is, you know, at the, think of it as a distribution, and you have the D1 and D2 where we have the VPC domain, right? So and then you have the two hosts, H1 and H2. Think of my CSR 1000 over here. It's running 17.x release. Think of this as the core router, and from there, you know, we have connectivity to the internet, right? So we are going to configure everything here. So that, I mean, I like doing that because that way you guys can replicate the whole lab, right? So start with let's start with the simple thing, which is the core device here. There's already an IP address put on the gigabit 3, I believe. Let me check that. So interface brief, yeah, so there you go. I have a IP address, and I've also configured NAT, you know, on the outgoing interface, which is gigabit 3. Maybe I can quickly show you that as well. So run interface gig 3, right? There you go. So this is the IP address, and this is the NAT outside, and it's basically now able to talk to the internet, right? I can do ping 4.2.2. There you go, right? But what do we really need to configure is the ones on the left side, which is gigabit 1, 2, and we need to put a port channel here. With respect to this particular core device, right, it doesn't really know about VPC, right? Because it looks at this D1 and D2 as one single switch, right? That's the whole idea of VPC, to combine into one single switch. So because it's looking at D1 and D2 as one single switch, so with respect to the core device, right, whatever it is, it's going to appear as if it is a normal port channel, right? So this yellow circular thing over here, it's basically nothing but going to be a port channel. So with respect to the core device, it's just going to be a normal port channel. All right, how do we configure the port channel? Pretty simple. Let me clear the screen and go to the top. Hope this is visible. Maybe yeah, so I think it should be visible. Let's go into conft. Let's go to interface port channel 1 probably, right? And that's no IP address because it's all L2 port channels. Actually no, yeah, I would want this to be L3 port channel anyway. So we are gonna put a VLAN over there. So what we're gonna do is start with interface port channel, no IP address over here, right? And then what we can do is let's define the members which are going to be part of this port channel, which is interface gigabit 1, right? And this one also is not going to have any IP address as such, but we need to define channel group, right? Channel group 1 is going to tell you which port channel this particular interface belongs to. So it's going to be channel group 1 mode active, and the 1 over here basically maps to this port channel 1, right? Pretty simple, pretty straightforward. Then we'll go to gigabit 2, right? That is important, and we're going to replicate the same thing, which is no IP address, but we will put channel group 1 mode active. Sweet, looks good. Now we wanna put an IP address as well, because we want this guy to be like a layer 3. We want this core device to be like the default gateway for my inside network. So what I'm gonna do is I'm gonna create a sub interface. How do you create a sub interface? So create a sub interface. You basically, in our case, we're gonna create a sub interface on the port channel itself, right? So we're gonna say interface port channel. Did I do something wrong? Channel, or okay, let me come out of here. So let's do interface port channel. Okay, yeah, port channel. We already have port channel 1. I'm gonna put a dot, right, and gonna put 100 because I want the port channel. And the encapsulation, right? When you define a sub interface, you need to define the VLAN, the encapsulating VLAN as well. So it's going to be encapsulation.1q 100, right? So that's the whole VLAN. 100 is the VLAN which we are using for the servers to talk to each other and also probably to talk outside, right? So we have .1q 100, and here once we have defined the sub interface, we are good to go and put in the IP address. We're gonna put something like, because this is the default gateway, I'm gonna say 172.16.100. Probably 254, right? 255.0, right? I'm gonna say no shut, right? And also this interface or this sub interface also has to be the NAT interface as well, right? So it has to be the IP NAT inside, because whatever traffic comes on here, it has to be NATed out, right? So what we have done right now is we have created just this port channel, nothing complicated, right? We just created this port channel. We took the interface gigabit 1, 2, bundled them into port channel 1, and then we defined a sub interface 1.100, because all the traffic which will be coming, right, it will be coming with VLAN 100. So we want to capture all that traffic into this particular port channel 1.100, which is a sub interface, and on that we define this IP address, which is 172.16.100.254. And like I said, the port channel is also going to act as the IP NAT inside interface, and this gigabit 3 is going to act as IP NAT outside, right? So right now the port channel would have not come up because, let me see, show IP interface brief. Ideally it should be down. Yeah, there you go, it's down because we haven't configured the other side of the port channel yet, right? Because our VPC is still not up, that's why. So let's do that next. All right, so when you go to, say, which is our D1, right? Let's go back to the diagram. So this is our D1 and D2. So now we are configuring this. There are a lot of things which are going to happen here, so be careful. Just be alert, right? To start with, what is the first step? Let's go and enable the fee, because it's a Nexus device, right? Nexus 9 kV. Let me show you what version I'm running. Show version. There you go. Yeah, there you go. So 935, guys. Okay. That's the version which we are running here. I mean, I'm pretty sure it should work with any version because this VPC is a very, very basic feature. That being said, let's enable some basic features which are needed, right? There are going to be 3 features which are going to be needed. One is the VLAN feature, then we want LSCP and VPC. So we are going to enable those first. There you go, right? So we enabled those. Very good. Next is, let's quickly create that VLAN which we want. VLAN 100, right? And let's, I don't know, maybe we can call it as, we can give a name and we can say servers or something, right? So that's the VLAN which is needed because all the server related traffic, right, all the host traffic is going to be tagged with that particular VLAN. That's why we need that particular VLAN, right? Next, the first thing in my VPC is, when you're configuring VPC, the first thing is we need to create that VPC domain, right? And the domain ID has to be same on both the devices. So what is the VPC domain? I can create, let me just clear the screen so that I go up. VPC domain, and I can give any number. I can give 10, right? Then the peer keep alive, right? Not peer gateway, not peer switch, peer keep alive, right? And what is the destination? The other switch, which is the D2. And what's the IP address for that? 192.168.1. Give me a second. Yeah, 1.2, I believe. Let me quickly check that for you. Show run, I think, section management, probably. I don't know. Let's see. Give me a second. Yeah, so the other interface IP on the other side, which is the management interface, right? So if you look at my diagram, you see there are 3 interfaces going around here. We have Ethernet 1/11, then we have Ethernet 1/10, and then you see there's one more interface which is the management 0. So the management 0 interface is the one which we are going to use for reachability purpose. And you see on the other side the IP address is 192.168.1.2. So let's use that, right? So that's the destination IP. And what is going to be the source? The source is going to be obviously the IP on my side, which is obviously going to be 192.168.1.1. I've already configured that management IP, so that's why you don't see me doing it now. Good. So once we are done with that, what do we do? So actually, let's quickly go and dump the same thing on the other side as well, right? So which is the D2 side, just to make sure that we are doing everything in sync, right? Okay, there you go. So I've enabled the features and I've enabled the VLAN as well. The other thing is obviously configuring the VPC domain, which is same as what we did on the other side. Only the difference is the destination is going to be D1 and the source is going to be D2. All right, happy with that? Yes. Let's go back. So the next is, let's continue our configuration on D1, right? What do we do next? Let's configure this particular, so right now the 3 things we'll have to configure, right? We would basically need to configure 3 port channels. I mean, the VPC domain is one single VPC domain, which we have already configured, VPC domain 10, but we have literally 3, virtual port channels. Which are those 3? The red one over here, the purple one, and the yellow one, right? So on each of these devices, we'll have to configure 3 port channels, and we'll have to basically tell the Nexus box that these 3 port channels are indeed virtual port channels or VPCs, right? So let's do that. So the first one is probably, let's do the one on the top, right? We'll do that. Or okay, there's one more thing. There's one more actually. You see there is at the center over here, there's another port channel which is basically the peer link, right? So actually let's start with that. That's a good practice. Before you actually configure the VPC, let's get rid of this peer link, which is very much needed for the whole keep alive purpose, right? So let's quickly do that. So it's going to be interface port channel, and we're going to call it 10, right? The switch port is going to be mode trunk on this one. Switch port mode trunk, right? This I mean, we are basically you don't have to tag the traffic by, I mean, you can if you want to do it, but I'm gonna keep it default, which means it's gonna use the native VLAN on this particular port channel, which is the peer link. And what else should we do? There's another important best practice, I would say, in VPC design, where they say you need to change the spanning tree port type from normal, right? So there is, you should have normal, edge, and network for your VPC. The recommended one is to have network, right? So that's something you see here. Spanning tree, yeah. So as per the recommended, yeah, cool. So you change the spanning tree port type to network, and the last part would be we have to tell the Nexus switch to kind of we have to tell it that this particular port channel is acting as the peer link. So you say VPC peer link, right? Pretty simple. There you go, right? Here you go. This is what this is why we change the port type to network in order to make sure that we use this bridge assurance, right? You can read a lot about it later. Not very relevant to our discussion right now, but yeah, I just wanted to point it out. Anyway, so we have configured the peer link on one side, right? Configuring the peer link is done, which is the port channel, but what are the member ports of this particular peer link, which is Ethernet 1/10 and 1/11. Let's quickly do that as well. So how do you do that? Interface Ethernet 1/10, right? Switch port mode trunk, pretty straightforward stuff, right? And the channel group is important. Channel group. What is the number? 10, right? See, this is my port channel. Where is my port channel? It is 10, so I'll have to go with 10 mode and active, right? Pretty much same thing for the other interface as well, which is interface 1/11, right? Let me just copy this one here, and let's do channel mode 10 active. Yeah, done. Sweet. So we are done with a bunch of things. So let me quickly grab the same config, right, and do it on the other side as well, which is the D2 side, because it's pretty much the same, no difference at all, right? So we will configure the port channel. Let me just grab it from here and paste it here. Yeah, right, pretty straightforward. So we have the peer link configured as well. What else is needed? Now I think we are good to go and configure the 3 port channels, which are very important, which is, so here what we are going to do is we are going to use the port channel number 111 for this one, right? This is 111. This is going to be triple. It's going to be or it can say 111. This is going to be 112, and this is going to be 100. The yellow one is going to be 100, right? So let's get to it now. So let's start with the first port channel, which is, let me just clear the screen, right? So we'll say interface port channel 111. And switch port mode, obviously, what is it? Trunk. And the VPC number is very important, right? Because this VPC number has to match on the other side. Why do I say that? You see, this is the orange, this is the orange or the red one, whatever it is. So we are going to define this VPC as 111, right? So this, the 111 number which you use over here, right? It has to, the VPC 111 has to be the same which you configure under this interface here, Ethernet 1/2 on the D1, as well as, you know, Ethernet 1/2 on D2, right? So that has to be same. So that's why that is important. So this port channel number is locally significant, doesn't have much value, but the VPC number is very important, right? This VPC, the 111 which I wrote just now, That's important. For me, in order to avoid confusion, I've kind of retained these both to be the same numbers, but you really don't have to, right? So that's very important, right? So we are done with the port channel, but like I said, we have to now go to the interface Ethernet, which was the interface 1/2, right, which I was showing you, and switch port. It's pretty simple actually. I mean, just like how you would configure your normal port channels, just you need to be a bit alert with the whole numbers, right? So what is the number going to be here? We want this interface to be a member of this port channel, right? So we're going to say 111 and mode and active, right? Exactly the same stuff goes on the other side. So let me do that. So I'm doing it one by one so that you guys don't get confused, right? So let me do that quickly. There you go. That's done, right? So we are done with what? We are done with, on the D1 side, we are done with the configuration for this one, right? Let's continue and do the configuration for this guy. That's just 112, which is very, very similar to what we did here, just the number changes, right? So it's going to be interface it's going to be 112. Then we will obviously going to have switch port mode trunk, and then we will go to VPC. What is the VPC number? Now it's going to be 112. That is what we are going with. And then the interfaces, which is the interface here. Let's go back to the diagram. It is Ethernet 1/3, right? So we have, let me see, did I? Correct. So it is interface 1/3. You can see this interface is connected to A2, and here also 1/3, right? So we can do that. So we'll go to interface 1/3. Obviously switch port mode trunk, and channel group is important. So we'll do channel group, and what is the number? This time it is port channel 112. So it's going to be 112 here, and it's going to be mode and active. Okay, that looks good. Again, same exercise. Let's grab the whole thing and put it on the other side as well. Great, awesome. There's only one left, which is the yellow one here, right? So that's the port channel 100, right? So, and the interfaces are Ethernet 1/1. So let's do that quickly. So let's go back here, interface port channel 100, right? Switch port mode trunk, and then we're gonna have VPC 100. Okay, and the interface is Ethernet 1/1. Switch port is mode trunk, and then channel group is going to be what? Channel group is going to be, we want this interface to be member of this particular port channel, so it's going to be 100 and mode active, right? Let's do the same thing on the other side, and by that we have completed all the configurations needed on the distribution switches, right? Now the only thing left is on the access layer, which is A1 and A2. So from A1 and A2 is very similar to what we did on the core device, right? Because from their perspective, they really don't know what VPC is. They are just gonna take these two interfaces and they're gonna do a normal, port channeling, how you would do a normal port channel, right? LACP port channeling, because they have no idea about what is happening on the other side, right? VPC, all of that is kind of locally inside this domain. It's not spilling out, right? So let's do on A1. What do we need on A1? So let's go to A1 here. Right, that's my A1. The features which are needed here is going to be VLAN and LACP. So let's enable those features because this is Nexus. You really need to enable the features. Let's also define those, the VLAN which is needed, which is VLAN 100. Very similar what we did, right? Let's quickly get that done on A2 as well, because that's going to be same on both the sides. All right, so next what? Now let's again break this down, right? So we will create the port channel, which is you can again use a different number if you want, but I like to keep everything constant, right? So I wanna go with something like this, right? So just so I wanna go with for this one I wanna go with 111. This is gonna be 112, and this is gonna be 100, right? So even when I'm configuring here, I'm gonna use the same number. Sweet. So let's do that. So let's quickly go to my A1 here. So it's going to be interface port channel 111, switch port mode I think trunk, right? And then what is the interface? Let's go back. I forgot the interface. It is Ethernet 1/1 and 1/2. Okay, interface Ethernet 1/1, switch port mode trunk, channel group is going to be what? Channel group is going to be 111 mode active, right? Similarly, the other interface is going to be which one? Interface 1/2, switch port mode trunk, and channel group 111 mode active, right? And yeah, I think that's good, right? And obviously, if you want, we can also enable, we'll also do this, because you see Ethernet 1/3 is the one which is connecting to the host or the server. So we want that particular server to be in which VLAN? We want it to be in VLAN 100. So we can quickly do that as well. Ethernet 1/3, switch port, this is going to be an access port, right? Access VLAN 100. Did I do something wrong? Switch port, okay, there is no mode, my bad. So it's going to be switch port, access VLAN. All right, done, right? Pretty simple. So we are done with the whole configuration on A1. Let's replicate the same configuration on A2 quickly. Okay, so on A2, what we only changes, we are going to change from 111 to 112 here, right? Because that's the port channel which we want. Obviously the mode is going to be switch port mode trunk, right? And let's quickly configure the interface Ethernet 1/1, which is again switch port mode trunk. And then obviously I'm just copying it from my notes here, but you get the gist, right? Because we just now did it on the other side. So that's good, and we just need a couple more interfaces, which is Ethernet 1/2 and 1/. Let's quickly drop those because pretty straightforward. I just did it on the other switch, so you should be good with those. All right, guys. So are we good now? Are we good? Let's see. I can see the port channel has come up on the core device. So let's quickly investigate what is happening. So on my core device, if I do show VPC, show IP interface brief, right? There you go, my port channel has come up, right? I can also ping the internet from my port channel. So I can do ping source it from where? From this guy, right? See, I'm able to ping. So everything is good on the core device. Let's see on my distribution devices, right? So I'll do show VPC here. Okay, there you go. So what has happened? You can see the peer link, which is port channel 10, right? The interfaces, I believe it is what, 1/10 and 1/11, like these both guys, right? So the peer link, which is port channel 10, has come up, and you can see the 3 VPC or the virtual port channels which we have configured. The 111 and 112 are towards the down, right? It's downlinks towards the access switches, and this one is towards the core device, right? So all the 3 VPCs are up, right? We can quickly check the same thing here as well on the other switch, which is show VPC, right? And you should see the port channel is up, which is between the peer link. This is the peer link is up, and all the 3 port channels or the VPCs are up. Okay, so that looks good, which means there's nothing to check on the access switches A1 and A2 because it's not very significant at all. We just have configured your normal port channels. So we can, if you want, we can quickly check show IP interface brief, show IP interface brief. Yeah, okay, it's not even going to show up because it's a L2 channels, right? L2 port channels. Anyway, so let's go to my host one, right? I think I clicked on end there, so let's wait for a couple of seconds for it to time out. Right, so on the host device, what do I have? Show IP interface brief. You see, I mean, my host is nothing but another IOL router, right? Because just for experiment purpose. So we have Ethernet 0/2 with the IP of 172.168.100.1, right? My default gateway is 172.168.100.254. So let's see if we are able to ping that guy. Ping 172.16.254. Okay, there you go. We're able to ping, right? Now let's see if you're able to ping the internet, which is 4.2.2.2. Awesome, right? So our VPC is literally working, right? So we are able to, we can also check from the other side also if you want, right? So let's go to enable. We can do a ping 4.2.2.2, right? There you go. That worked, right? So that was as simple, right, to configure the whole VPC. All right, just to summarize what we did, was we set up this core device first, right? And we set up a normal port channel on the side of the core device, because with respect to the core device, it really doesn't know what VPC is. Then we came to the D1 and D2. We set up a VPC domain here, and we set up first we set up the peer link, because that's very much important for the whole Keep Alive to flow around, right? So we set up the peer link. The reachability was we used the management interface, and then we configured the 3 port channels, or the virtual port channels. 2 of them are here, right, towards the servers, and 1 was towards northbound, which is basically towards the core device, right? And we also did a bit of configuration on A1 and A2, but again, like I said, with respect to these devices, they really don't know that they are really participating with a VPC device, right? For them, they're just gonna, whenever they look up, it appears as if this is one single switch, right? So with respect to them, these are blind, straightforward port channels. So that was literally what we did, and finally we tested that we were able to actually talk to the internet from H1 and H2. Okay, so hope that configuration was useful, and thanks a lot for watching.